Hi everyone, we're back in this Modern Campus Network Design series. We hit trends and challenges, moved into campus architectures, and covered some cool concepts related to cloud, edge, and hybrid solutions. Now we're ready to move on to NMS evolution.
I want to talk about typical industry solutions, best practices, and technologies, starting with issues related to disparate systems. In the first video of this series, I talked about classic network management systems, or NMS challenges. Separate systems in different regions of your deployment make it difficult to see national or international patterns and trends. Then you have these separate silos based on technology, WLAN, LAN, and WAN connectivity to remote offices and services. Now, this means that to troubleshoot a problem, you must often manually move information from one tool to another tool to discover the root cause of an issue. Suppose you have some host having issues on the WLAN with a particular MAC address. You need to pull data from the wireless system about APs, SSIDs, and controllers, from the LAN system about switches, ports, and status, and perhaps from the WAN system about routers, paths, and Layer 3 security. Then piece all that information together and puzzle out a solution. Now, the same holds true for configuration management. You want to add a new WLAN, so you access the WLAN system to configure APs, SSIDs, VLAN mapping, and WLAN security. Then access the LAN system to configure ports, VLANs, Layer 2 security, and maybe quality of service or QoS and trunking. Then perhaps access the WAN system to accommodate this new WLAN with the appropriate subnetting, routing, and Layer 3 security. This all might be in 3 different tools with 3 different approaches. Now, automation can be built, but you're still stitching together these disparate systems. It's frustrating. The industry is responding with a couple of key approaches. For example, vendors are starting to combine strategic elements into unified management tools, allowing pre-packaged turnkey approaches to unification. And some organizations write completely custom tooling to pull together automation or information from multiple systems. Now, these solutions can get labor-intensive, and they might not provide the tight integration you're looking for, but they help. And they can get one aspect of the equation right by allowing for a multi-vendor environment. NMS evolution means that you must be able to integrate with many different solutions. I think Aruba's approach is pretty cool, unifying these disparate systems into a common platform with a common data lake, wired, wireless, and WAN across your entire deployment. Now, this common big data pool can be analyzed with cloud-based AI and ML systems to detect trends, see patterns, and alert you of impending issues, and advise you how to handle those issues. And Aruba's Edge Services Platform, or ESP, ties this all together with Aruba Central giving you a single portal into all that information and intelligence. But NMS evolution isn't just happening in the cloud. It's also happening in the fabric of our campus networks, in the switches, multi-layer switches, and controllers at the heart of your campus architecture. For many years, network admins have been dealing with the old Simple Network Management Protocol, or SNMP, which has evolved from version 1 to 2.3c and on to version 3, which includes more robust security mechanisms and some efficiency advantages. Now, it still works okay, but its pole-driven approach to telemetry is a bit dated. It remains heavily used, but there are opportunities to find a more streamlined, universal approach to configuring, logging, and diagnosing these systems. And the old command line interface, or CLI, with flat text configuration files is getting a bit old-fashioned as well. The old CLI is great for human-to-machine interaction, but not so great for machine-to-machine interaction. It just doesn't lend itself to the scalability and ease of management requirements of modern campus designs. Well, wouldn't it be nice to have a unified infrastructure with a single operational model across the infrastructure? I like that the Aruba CX switches are built on a microservices-based operating system with an open REST API, available for configuration and management functions. You get easy, secure cloud connectivity with modern HTTP-based telemetry that uses a more optimized publisher-subscriber model as opposed to the cumbersome polling method of SNMP. This facilitates zero downtime upgrades and moving to a more centralized control and management plane, in cloud or on premises. It also facilitates more automation related to typical network administration tasks. In scalability, a single customer can manage up to 100,000 network devices and 1 million client devices. Check it out. By zooming in on one of these switches, inside you have a CPU board and kernel with all management, history, and protocol and network analytics based around a stateful database. Of course, you have high-speed communications down to the application-specific integrated circuits, or ASIC hardware, for network connectivity. Now here's the cool thing. You can access all this modern internal architecture using the same command line and graphical interfaces you know and love, but are also ready to take advantage of that REST API for cloud-like services, automation, and more. Another aspect I love about these modern devices is the continued march toward a kind of optimized edge cloud delivery model. Networking used to be about simply moving the packets around. But as the infrastructure got more complex, tools were needed to optimize, upgrade, and provide additional value to the businesses leveraging them. Vendors have capabilities like this that come in many flavors. Some of these may include integrations to third-party systems to automatically trigger things like prioritization of voice and video flows. Now, we've been seeing a move towards this kind of thing for years with things like the Aruba Wi-Fi solutions. You may have 1,000 access points or APs, but you don't manage 1,000 APs, right? You manage a few mobility controllers, perhaps all overseen by a mobility conductor, all of which helps to automate management functions. And this trend continues with the ability to move those mobility conductors into the cloud, giving you ever more centralized services. And we can leverage this functionality for our wired LAN solutions as well, with solutions like Aruba OS CX and Aruba Central management solutions. Aruba has been working towards moving all their service functions into an edge cloud delivery model. By doing this, they can deliver services ranging from automated RF planning and optimization, in-production upgrade service, and energy-saving services, contract tracing, and more. Okay, that concludes the NMS discussion, evolution with tighter integration, AI and ML, and the edge cloud delivery model. I hope you come back because this next topic is a good one. It's all about security.